Okay, so what we're going to talk about today is the inverse of an exponential function. So all day yesterday we spent finding inverses of functions, right? We didn't talk about exponential. The reason being is because we haven't ever seen the inverse of an exponential before. The inverse of an exponential is what we call a logarithm. They can be a little tricky, so they take a little practice, and you have to have kind of a piece of it memorized in order to do it. Okay, so again, what happens when we want to find the inverse of an exponential? Well, the inverse of an exponential is a logarithm. Now, in order to go from exponential to logarithm, in order to find that inverse, you have to know how to go from one general form to another. So here's our formula. We've got y equals b to the x, right? That's what part? Exponential or log? Exponential, okay? This turns into log base b of y equals x. Notice what's here. B, that's our base, right? That's our base, okay? So if I were to set this log on a table, what would it sit on? B, which is its base. What's this piece? That's what my exponential is equal to, right? And then this is my exponent, okay? So we're always equal to the exponent, okay? Always equal to the exponent. You got it? What did I just say? Okay, so b to the a equals c. How would I change this into log form? Log, what's the base? B of equals a. Yes, when we're going from exponential to log. So this is, they're inverses of one another. Okay, so we're going to be going back and forth in between the two. Okay, all right, so now we have to practice going back and forth. And it does take a little practice. And if you need to go through and label what each one of these is going to be, then label them. Okay? So again, we had b to the a equals c, log base b of c equals a. Okay? So let's label this one. 25 equals 5 squared. Is that correct? Is 25 equal to 5 squared? Yeah, absolutely. Okay, so what would 25 be according to this? C. It would be C, right? What would 5 be? Which is B. And what would 2 be? A, right? Okay, so now we know A, B, and C. We should be able to very easily put this into log form. So log of 5, log base 5 of 2. Well, log base 5 of 25 equals 2. Okay, so another way to think about this, if I were to kind of ignore that log, pretend like it's not there, notice what's happened to these two values from here. They kind of like switch spots. Okay, so if you're ignoring this log, pretend like it's not here. Okay, 5 to the 25 equals 2. What do? We switch those two values. Do you see? I'm sorry? Okay, now, calculator has a special key. See it? Control 10 to the x, right here. I guess black isn't going to show up. Okay? And that'll work for you. All right, so I want you to try the next 3, and then we'll come back and go over them together. Good. So if you need to label them, if that's what gets you through it. Okay, so 729 equals 3 raised to the 6th power. Who wants to give it to me in log form? Thank you. Base 3 of 729 equals 6. It's always equal to the exponent. Always equal to the exponent. All right, somebody else give me the next one. Log base b of log base 1/2. Yep. Good. Log base 1/2 of 1/8 equals 3. Excellent. Yeah. Control 10 to the x, log base 1/2 of 1/8 equals 3. There it is. Okay. And that actually brings me to a really important point, which we're going to talk about in just a minute. Let's do this last one. Who wants to give it to me? Log base 10. Good. Are we good? All right, now let's talk about notation here. Log base 10 of 1 equals 0. What do you notice about the 10? Tell me about its characteristics. It's smaller. It's below. Okay. It's smaller and it's below. What do you notice about the log, the 1, and the 0? Yeah, these are all on one same line. Okay. The only thing that's been dropped down a little bit is the 10. Got it? Does this mean 10 to the first power? Have you ever seen a little number raised to a giant exponent? Okay, this is not exponential. This is not an exponent, has nothing to do with an exponent. This is just log form. Okay, so I don't want to see this 1 written as an exponent. It's not an exponent. Okay, and that's a mistake a lot of people make, so be cautious of that. Okay, so next page, guys. To evaluate logarithms, we can write them as exponentials and solve. So that's something important that you need to be able to do. You need to be able to go from exponential to log and then from log back to exponential. Okay, kind of that back and forth. So if we look at the first one, log base 8 of 64 equals x. And if you need to do this, then do it. If you need to write it on top of your paper every single time, write it on top of the paper. Take the extra step. Don't be lazy. Okay? So what's b? What's b? B is 8. What's a? X, good. And what's c? Good. 8 to the what power is 64? 2. Excellent. Okay, so all I did was I went from log form to exponential, and then I figured out what the value of x was. It's not bad, right? Okay, question. Is this the same thing as this? Yes, absolutely. Okay, just because the equal sign's on the other side of the equation doesn't mean it's different. It's the same exact thing. Okay, so you're going to see it written both ways. You have to be able to look at it when it looks like this and know it's the same thing and pull out the A, B, and C. It's the same. Okay, so don't let that trip you up. All right, so try the next 3, and then we'll go over them together. Okay, let's do this first one. Log base 4 of 1 over 64 equals x. Somebody put it into exponential for me? 4 to the x equals 1 over 64. Excellent. Yeah, x would equal -3. Great job. Okay. How do you get, well, 4 cubed is 64, right? Because it's 1 over, you make that exponent negative. Got it? Okay. Next one. Log base 3 of 27 equals x. Somebody put it in exponential for me. 3 to the x equals, equals 27. And then x would equal 3. Great. Getting the hang of it? What's 3 cubed? 27. Okay, great. Let's come down here. Exponential. So what does x have to be? Great. How do we do? Not so bad, right? You just have to know how to go back and forth. Okay. So a common logarithm is a logarithm with a base of 10. When we have a base of 10, we don't write it. Okay, we write it without a base at all. So if you see something like log of 13, and there's no, that's an iog. It's not what I meant. Where's the L? There you go. So if I have log of 13, no base is written, what is the base? 10. Okay, it's assumed. Just like when we look at the square root, right? Square root of 4, what's the index? 2. It's assumed. Do we write it? No. Okay, so with a common logarithm, the base is 10. Okay? All right, so let's take a look at graphing now. Now, we know that the inverse of an exponential is say log. We also know that the inverse of something is simply a reflection over what line? Y equals x. Great, we talked about that yesterday, right? So we know that when we're solving algebraically to get the inverse, what's my first step? How do we always start algebraically when we want to find the inverse? What do? Switch what? The y and the x. So if I'm taking y equals 10 to the x, my first step algebraically would be to do what? Yeah, x equals 10 to the y. And then from there, I would go to my log form. Log base 10 of x equals y. Okay, so these two right here are inverses of one another. So when we graph them, it should be a reflection over the line y equals x, if I've done it right. Okay, so on the next page, 10 to the x is already graphed. We're going to go ahead and graph log base 10 of x. Should I make this go away? Okay, I'll wait. Okay, so on the next page, I already have 10 to the x graph. What were we going to graph? Log base 10 of x, so control 10 to the x. And I'm going to put in the 10 just because I know what it is. And x, I think if you leave it blank, it'll also assume that it's 10. Okay. And hit enter. What does it look like? Does it look like a reflection over the line y equals x? Sure does. Okay, what do you notice about that red curve? The red curve, the log base 10 to the x. Okay, just not in relation to anything else, but itself. What do you notice about just that curve itself? We always move left to right. Doesn't touch what? It does not touch the y-axis. Excellent. It never touches the y-axis. Why? Say that again. X can never equal 0. Because the first one never touched the x. Yes, it did. Touched it right here. Oh, right. Good. Okay, right. So with 10 to the x, the asymptote was the x-axis, right? So when we said we have the inverses, what do we do with domain and range when we have inverses? We flip them. So the domain becomes the range and the range becomes the domain. Okay, so with the original, this was our asymptote, our y equals 0. With this one? Yeah, kind of. Okay. What essentially is happening here is you can never have a negative logarithm. Doesn't happen. Am I ever creeping over into negative x values? No, I'm never going to have any negative anything inside of my logarithm. No negatives. Doesn't work. Can't happen. Okay? So we can never have any negative x values. All right, so let's talk about transforming these. Transform means to what? How many of you have transformers? Had when you were kids. Okay, what do? What does that mean? They change, their pieces move around and they become something else, right? Okay, so a translation in math means what? It slides, it moves, okay, usually horizontally and vertically. Sometimes we stretch them or shrink them. So let's talk about that. Okay, so on the next page, I've got y equals log, shrinking, right, dilation, yes. Good. Okay, so we're going to add a graph page, and we're going to graph this function right here. Okay, log base 6 of x minus 2 plus 3. So control I, add graph. Here's my function. You have to add one, honey. Control I, add graph.
See, I think it's control doc.
That's the same thing.
I know.
What? I'm sorry? How do we know what?
No, wait, we're not trying to find the end.
No, right now we're just looking at the graph of it. Okay? Okay, so I'm going to put another function up here, and you tell me how this function is related to the one that's here. Stop it, Joe. How are those two related? What is the red function in reference to the blue function? There's a vocab word you have to know. Yeah, we did translate the blue function from the red function. So what is that red function called? Nope. Gotta know this word. Starts with a P. Popo? It's not Popo, honey. A.
Don't tell us. What's the next one? EA.
What is it? You said no, not paradox. Come on. I want to cry right now. I'm going to go home and cry right now. Yes, you're supposed to know this. I've said it like a million times. You said it earlier. And then you went on to paradox, so I'm not giving it to you. Not even a little. Paraline, huh? Nope. Parasol. Yes, that's it. It's the parasol. Parasol function. No.
What's that for parent?
Parental parentheses.
Oh my good Lord. It's the parent function. You have heard this. Okay. All right, so the red function is what we call the parent function. Describe to me what a parent function is. The main one, what does that mean? The original, before I've messed with it, right? So my red function would be known as my parent function, and then my blue function is the function that I have translated, okay? Now, how do you know what? Have you added anything to the red one? Has it been multiplied? No, it's the original, hasn't been messed with, okay? All right, now I'm going to send you a quick poll. You are going to tell me how it has been translated. I want math words, please. Please do not tell me, sliding isn't going to work for me. Let's not give me points. That's not what I want. I want you to describe the translation using mathematical vocabulary. Can we handle that one? Not like paracel or paratroopers or anything like that. Okay, so I'm going to send you a quick poll. Okay. So you're going to describe to me the translation. You got it? So once you have it typed in, you're going to hit doc enter to send it back to me. All right? I will have it. There shouldn't be a first letter. You're not giving me a word, dear. You're describing the translation. You're going to, slid isn't a word. You're going to, I would love to tell you if you'd stop talking at me. You're going to describe the translation from the parent function to the new function. How has it changed? In your words, with words, you are going to describe to me how it has changed. It's moved 2 units to the right and 3 units up. That's very good. It's moved 2 units to the right and 3 units up. That's wonderful. We could say it's translated horizontally 2 units to the right and vertically 3 units. up, right? When subtracted from the parentheses, the new function slides to the right. When adding to the function, it moves up. Great, excellent. It has increased and become more positive, not even a little bit. It has moved and does not intersect. No, we're not going to use that one either. It's moved up 3 and moved to the right 2. Good. It's shifted 2 over on the x-axis and up 3. Good. All right, so most of you have got it, right? You get what it's doing. So we have gone 2 units to the right and 3 units up. That's the translation. Got it? Okay. Your homework is in your packets tonight, pages 10 through 13. 10 and 11 are crucial. Make sure they get done. It's going back and forth from exponential to log, vice versa. Make sure that when it says solve, you give me a solution at the end, okay? The next 2 pages are graphing. Please make sure you get those done as well. You guys need to practice these.